Hi everybody, this video corresponds to the sheet from class today. It has the diagram on the front that says real numbers and the number line. Just a little recap before we get to that sheet though. We've already talked about both of these figures in this diagram here. The one on the left is a square root. The one on the right is a cube root, and these are just important ideas to know for the year. We said these square root symbols, or a cube root symbol, the piece around it, in both cases, is the radical. The piece inside of it, so in both pictures, the x is the radicand, and the number here is referred to as the index. Now you'll notice in the square root there's no number there, but it's kind of imaginary in a sense, okay? We call it a square root. Well, think about what happens if we square something, right? It looks like that, x squared. So when there is nothing written in the index position, it's really like a Choo is there. Okay, so this is what the front of your sheet should look like. All of these are real numbers. This year, everything we're going to talk about is real numbers. You will get to imaginary numbers in Algebra 2, and those are basically when you try and take the square root of a negative number, which should make sense to us that we can't do that. So the big categories are rational and irrational, and then you can see on the left, rational breaks down to integers, which breaks down to whole numbers, and then counting or natural numbers, and those two terms are used a little bit interchangeably. So let's start in the smallest part on the left, the counting and natural numbers. The way I always remember this is if you ask your little cousin to count to 10, they start counting 1, 2, 3, and they continue. Okay, so starting at 1 and it goes all the way up. However, whole numbers, the only difference between that is now 0 is included. Integers we've already worked with a little bit through some of our sprints. It includes everything from the whole numbers. Okay, we can do the ... there. But now it also includes negatives. Okay, so we can go backwards. So you can see as I go out in the boxes in the diagram, more numbers are included. So rational numbers consist of integers, whole numbers, counting, natural numbers. However, they also include a few different things. They could include fractions. So 1/2 is rational. They could include perfect squares, which we talked about means when you take the square root of it, you get an integer as your answer or a whole number as your answer. So let's say square root of 25. Okay, it could include any regular number that we want, 19. It could include a decimal that ends, so let's say 19.5, or a decimal that has a repeating pattern. If it does not have a pattern, that's when it becomes an irrational number. So for instance, 7.1354629 and so on. There's no pattern between the numbers there after the decimal point, so that's irrational. Pi, which we use as a symbol, we don't do 3.14, 22/7 anymore. Okay, that's an irrational number. Continues on forever and ever, does not have a pattern. And the other irrational numbers are square roots that are not perfect squares. So for instance, 11 is not a perfect square. 26 is not a perfect square. All of those are then considered irrational. Okay, if you flip to the back of your sheet, this is an extremely important concept, one that I definitely want you to know for your test and for the rest of the course this year. So we want to decide, now that we know what rational and irrational means, what about the sum of rational and irrational numbers and the different combinations that could be formed? So if you look on the top there, you have A through H, and all they're doing is giving a letter or a variable and telling you what number it's equivalent to. So for instance, A is the square root of 3. Hopefully you all can agree with me that that's an irrational number. I'm just going to put a little I next to it then. Okay, you can write the whole word out if you want. Continuing, B is equal to the square root of 25. We should all know that that's 5, which means it's rational. It's a perfect square. So continue on through C through H. Okay, and decide if each one of them is rational or irrational. Okay, if you need to use your calculator at any point, you can. Okay, remember we've talked about how to type in radicals into our calculator. And then what you're going to do for 1 through 10 is see what you came up with and decide if your answer is rational or irrational. So I'm just going to do number 1 with you, and the rest is your homework. For number 1, it says a plus b, so that means square root of 3 plus square root of 25, or you could have written 5. And I want you to tell me, is that going to be rational or irrational? Again, you may use your calculator if you need to. And hopefully, I don't care what the number is, I just want to know if it's rational or irrational, and you should get that it's an irrational number. Okay, I want you to do the same things for 2 through 10. And at the end, see if you can come up with some generalizations at the bottom. Okay, and fill in those blanks. All of these here, these little blanks, the answer is either rational or irrational. That's what I'm looking for. Okay, and I'll tell you why this is important, this concept. It came up, I believe, on both Regents exams that have already been given in Common Core. Okay, and I'll show you a sample question. Okay, this was a question on last June's Algebra Regents. Okay, looks very similar to the handout that we're working on. L, M, N, and P are all given different values, and it wants to know which expression, which sum of those two variables results in a rational number. Okay. So just to go through with you again, for the practice, you can answer the rest of the homework. Radical 2, not a perfect square, irrational. 3 radical 3 is irrational. Radical 16, or remember we can say square root of 16, is rational. Square root of 9 is rational. If you go through the answer choices, the one that does produce a rational number would be choice 3, and I'd like you to go through and check that and make sure you agree with me. So for homework, you should be finishing the back of that handout, and then I'll see you guys in class tomorrow.